All right, let's talk about Google Cloud Firewalls. Look, if you're working in GCP, this is one of those things you just have to know, especially if you've got a certification exam on the horizon. So we're going to break it all down and demystify.
Here's how we're going to tackle this. First, we'll get the core concept down with a simple analogy, the virtual bouncer. Then, we'll get into the real nitty-gritty, the order of operations. After that, we'll see exactly how you build these rules, piece by piece. We'll also cover the ultimate veto power that can override everything. And finally, we'll put it all together with some classic exam scenarios you're almost guaranteed to see.
So I love this analogy. Think of a GCP firewall as the bouncer for your private cloud network. It's standing at the virtual door, checking IDs, and deciding exactly who gets in and who has to leave.
And that really begs the question, right? In the cloud, there are no physical server rooms, no routers you can lock up. It's all virtual. So how do you actually guard something you can't touch? Well, the answer is software. A GCP firewall is not some big, single piece of hardware that all your traffic funnels through. Not at all. It's a distributed, software-defined system. The rules you create for your virtual private cloud, your VPC, are actually enforced right at the virtual network card of every single one of your VMs. That's a huge difference from how things work on-prem.
Let's put them side by side. Traditional firewalls, they're hardware boxes sitting at the edge of your network. GCP firewalls, all software enforced on every VM at the same time. But, and this is absolutely crucial for the exam, notice that they're both stateful. What does that mean? It means if you create a rule to allow a connection in, the firewall is smart enough to automatically allow the response to go back out. You don't need a separate rule for the return trip.
Okay, so what happens when you have a whole bunch of rules? Maybe some of them even conflict with each other. How does GCP figure out which one to listen to? It all comes down to the order of operations, and honestly, this is a concept that trips a lot of people up. It's actually a pretty simple numbers game, but here's the key. The lowest number wins. A rule with a priority of 0 is the most powerful. It gets checked first. A rule way down at 65,535 is the absolute last resort. So when a packet of data arrives, GCP starts at 0 and just goes down the list until it finds the very first rule that matches that traffic. As soon as it finds a match, that rule is applied and the process stops. Game over.
That's a great question. What if a random packet shows up and it doesn't match a single one of the rules you've written? Does GCP just let it in, or does it get dropped? Well, don't worry. Google has a built-in safety net.
By default, the front door to your network is slammed shut and locked. Every single VPC has an invisible, unchangeable rule sitting at the very bottom of the priority list that says, deny all incoming traffic. So the most important thing to remember is this. Nothing gets into your network unless you explicitly create a rule that allows it.
Now, here's the twist. While the front door is locked, the back door is basically wide open. By default, any of your VMs can send traffic out to anywhere on the internet. This is a huge difference from a lot of traditional on-prem setups, and it's a massive security consideration. If you want to lock that down, you have to create your own rule to deny outgoing traffic.
All right, so we get the logic. Now let's crack one of these rules open and look at its anatomy. What are the actual building blocks? Every single firewall rule is made up of these 6 core parts. You've got the direction. Is traffic coming in or going out? The priority number. The action. Allow or deny. And then the specifics like the protocol and port. But the 2 most interesting parts are the targets. Which VMs does this rule apply to? And the source or destination filter. What specific traffic is it looking for? And this brings us to a really key architectural choice. You can target your VMs using simple text labels called tags, like you see here, web server. It's super flexible, but it's not the most secure because an admin with permission to edit the VM can just change the tag and poof, they bypassed your rule. The much better way, the architect's preference, is to use service accounts. A service account is a true cloud identity for that VM, and to change it, you need much higher level permissions in IAM. It makes your rules way more secure and robust.
So far, everything we've talked about has been inside one single VPC. But what if you're working for a huge company with hundreds of projects? You need a way to set security rules from the top down, right? And that is exactly what hierarchical firewall policies are for. Here's how it works. Before GCP even glances at the local firewall rules in your VPC, it checks to see if there are any policies set at the organization level or at a folder level. This is the absolute first gate that all traffic has to pass through. If, and only if, the traffic gets a green light from that top-level policy,
Then GCP will go and look at your local VPC rules. But if that hierarchical policy says deny, it's game over. The traffic is dropped right there, and your local VPC rules never even get consulted.
Okay, pop quiz time. This is a classic exam question designed to see if you're paying attention. You've got an org policy that denies SSH on port 22 with a priority of 500. But down in your VPC, you have a rule that allows port 22 with a much higher priority of 100. So who wins?
The org policy wins. It wins every single time. And that's the key takeaway here. Hierarchy trumps priority. A deny at the organization or folder level is an absolute veto. It cannot be overwritten by a local rule, no matter how low that priority number is.
Okay, we've covered a lot of theory. Now let's put it all into practice and walk through some scenarios, the kind you'll definitely see when you're sitting for a certification exam.
So, let's design the rules for a secure web server. First, you need an ingress rule to allow web traffic, that's ports 80 and 443, from anywhere on the internet. Makes sense. Second, you need a way to manage the server, so you'll add an ingress rule for SSH, but you'll lock it down to only your trusted corporate IP address range. And third, here's the pro move. You create a high-priority egress rule to deny all outgoing traffic. This helps prevent the server from being used to attack other systems or leak data if it ever gets compromised.
And now for the final boss. I call this one the stateful trap. Check this out. You have an ingress rule allowing web traffic in and an egress rule denying all traffic out, and they both have the same priority. A user connects to your website, their request comes in, and Rule 1 allows it. Your server processes the request and generates a response. What happens to that response on its way out? Does Rule 2 block it?
The response is allowed. This is that aha moment where it all clicks. Why? Because, as we said, GCP firewalls are stateful. They don't just see a random packet trying to leave. They understand that this outgoing packet is the response to an existing approved connection. That egress deny rule only applies to new connections trying to start from inside your server, not the return traffic for a session you've already allowed.
So let's boil this all down. If you walk away with anything, make it these 5 points. 1. GCP firewalls are stateful. 2. When it comes to priority, the lowest number always wins. 3. Hierarchical policies get checked first, no matter what. 4. For better, more robust security, use service accounts instead of tags. And 5. Never forget those invisible background rules, implied deny on all ingress and implied allow on all egress.
So now you know how to build the digital walls to protect your cloud network. But you know, building the walls is really only half the battle. The next logical step is to ask, how do you actually monitor who's knocking on that door? How can you see the traffic that's being allowed, and more importantly, the traffic that's being denied? But that's a great topic for next time. Thanks for joining me.